Good morning.
Good
Hello,
morning.
hello. Hi,
Hello.
how are
Hi.
you?
I'm all right. You?
I'm horrible. All right, so this is how we're going to go about it. What time Sarah come in?
I have no idea.
Yeah, but don't today I'm market week, so in the downtown I do some foolishness.
Oh,
Yeah, in their market I terrorize the poor people, them and I try ball down them price. Yeah, man. All right, so
mm,
what Sarah got through last week, and complete in the look back over what Sarah got through last week.
no, I have not. But I know. Let me get my book. Let me get my book.
Candice, good morning.
Kendix, darling, how are you, my darling? Say, I make London and go. I mean, like, we just move them.
Morning.
Okay.
You should buy one for me. I'm saying. How the shipping go if we like? Yes.
All right. So you got help me out this morning. My brain now work on the other day.
Oh, me?
Yeah, man. When my brain got on holiday.
I know I'm gonna take up a calculus book from last week. Honestly.
All you me think you would have passed last semester, cause the way I see you and your crew a move, me I say yo, me I link some of them on them. I say yo, me link some of them and me I say yo, help me out with this one. Man, I said no man, sir is saying,
First pass,
sir,
never pass, never pass.
how much people passed last semester in last class?
Well, majority of my class pass. I just me. I just go 4 away out of my class and pass.
Hello, I'm here to in your class, so me no pass either.
The ENI 4.
Yeah, man, just 4. I think a 4. We just 4 away.
4 away out of 11.
About
Okay.
that, about that, man. Yeah, cause AMIS the mix we do too. Aviana never get to do calculus, so she no come.
I'm telling you. I'm telling
Oh, I
you.
never turn. Oh,
What happened? What you say?
I just a pick up say you.
Oh, okay.
Yeah.
So I'm trying to figure out how can I not ski uphill for this exam, and we want to talk to some people on a one away where like where go
Mm.
like on a Sunday evening or something, we link up back and we run through the last set of questions we started doing that day or something because
I don't
trust me.
I don't have a problem with that because I finish working on Sundays. I finish working at 8, and depending on where I am, I get home by 9. That's we 1 hour ahead. So if I reach home by 9, that means at 8 o'clock for you down there. So if at 8 o'clock you can get me after that. But any other time from that, cause more work early morning to 2 job. So
Bomba.
yeah. From it's in the night, I have no problem. But if it's in early morning, I can't get to come and link up or not. You see me? But it is nice to have like group work, conversation that it actually helps because you cannot help a person and not teach yourself at the same time.
Yeah.
Sometimes you see me, and it stick better. So I have no problem with that. So once it's coming in, I have no problem doing it, and the exam is right around the corner.
True. Very true. Very true. Very true. When I exam again, when I exam
The
him say,
9th, me see the 9th.
yeah, me do my little calendar,
Mm.
exam the 9th, so I have exam on the 3rd, the 8th, the 9th, and the 10th. Jesus Christ.
As it was on the 10th first, and then it changed to the 9th.
Yeah, my one did a clash. I mean, one of them were going for me that they are clash with me on the 10th, the same day, the same time. All right.
I'm not sure.
No, miss out. No, miss out. What? So you know what time Mr. Shanna come?
No.
Oh,
What did more?
Sir, come and gone.
Oh, for sure. What you say?
You know, say nothing.
They say me can pop in and pop out.
Sir, look like him there before 8 o'clock.
sir, they are market, man. I know, sir, today, what I asked him last week, him saying they are market.
Every Saturday market day.
No, every other.
Every other Saturday off.
Yeah, I forgot market, you know? He
Okay.
make sure he meet off a whole lot of food by
What
the
you
time.
doing? You not gonna use it? What is
Hold on, them soon come back. Hold on a second.
Yeah.
We want to start on a market though. Oh, yeah. People. We forgot market, you know, I'm sure I'm going to market, you know. If I did ever remember I'm going to market. Man, for the man to come here going anytime soon, you know. In the reason, I'm not all in it. I'm living about 5-6 years now. In the reason. See, you various now. When I come to me with it, I just say, okay, I'm not going to do various. Him not must do it, but if you come to me with it, I'm mentally prepared. And the fuck you say anytime soon. Who can? So what you gonna do?
All right, good morning, guys.
Morning, sir.
Right, so I was here before. And I saw Candice, and then I am sitting and waiting for the others to. Yeah, I was here before Candice, waiting for others to come on, and then the computer just a blue screen just decided to come up on the computer. And Everton, please do not unmute, and I don't want to hear anything from you. I don't want to hear anything from you, Everton.
Just attack or market again.
No, man. So you never saw me? You never saw me online when you
Sir,
came
I tell you, say come on and come off.
No,
May I
man,
say I'm market again?
Is a computer decided to just show up this blue screen. And it took forever every time I turn on the computer, it just turn on and shut off. So I had to be going through that process about 2 or 3 times. No, man, I logged on from before. The earthquake kind of wake me up, so I was but oh Lord, this system needs to be changed. I need to change it. Anyhow, all right. So we are on integration, you see, but I'm also teaching business calculus, and what we are doing is what they are doing to some extent, and I wanted to let you know before I invited them. I told them about the class this morning. I told them that I'll invite them, those who can make it, to come on. So I didn't want to just put them in the class without telling you first. So with your permission now, I'm just going to send them the, Lord Jesus, Peter gave sent the link. I'm going to send them the link, and okay, okay, all right. So they're asking, so I'm going to send them the link, so at least you know. Peter can just send something all about, so just be nice to them and then come in. Then they are struggling with they just start the topic similar to you. So I just want to just spend some time this morning on the integration. When I'm moving on to other areas where they don't need to be here, I will just tell them bye-bye, and then they can go. And we're here together, but we're in this struggle together, and we just have to go. And so the center of the earthquake wasn't even in Jamaica, The center of the earthquake was in Port-au-Prince. And it was massive then. For it to spread out of us here. So anyway, Lord, I give thanks. All right, so I hear somebody just joined. Let me see if it's one of them. So you will see if you check the chat. No, it's none of them yet. You'll see. Oh yeah, Joan is here. Morning, Joan.
Morning, sir.
Right, and you look the calculus 2 students. I spoke to them about you guys joining, so if you can just send a message out, Joan, to the business calculus to say, we're here waiting. I have not yet started. I had some computer issues. So you can just send a message out to the folks that you're here and just invite them to come because I'm about to begin now.
Okay, sir.
Um, oh my Lord, are these the end times? All right, so I think that's time enough to give those students an opportunity to come in. So I am about to I'm about to begin calculus 2, applications of integration. All right, so remember now. So last time we went through the 8 rules of basic rules of integration. Now, I don't want anybody to think that there are only 8 rules for integration. Integration has many rules. Many, when I say many, plenty enough rules. All right. So what we're doing is going through. We went through the 8 basic rules of integration, and we no, I don't know. And we had a look at those basic rules. I had a look at those basic rules, and what we did was to apply some of those rules in answering some questions. Now, again, we're going to be continuing with those basic rules, and you will see them on the screen just now. And those are rules for integration. And just to say to you that, in a nutshell, when we're integrating a constant, we can just take the constant out, integrate, and then multiply the constant by whatever it is that we have. And if it is that we're talking about an indefinite integral, we must have our plus c, or constant of integration. When we're integrating 1, we don't write 1 dx, we just write simply dx. Very important. When we're integrating, we don't write 1 dx, we just simply write dx for the integration. In addition to that, we also spoke about writing the rule number 3, a very important rule, that when we're integrating, we add 1 to the power, and then we divide by the new power. We add 1 to the power, and then divide by the new power. So x to the n, when we integrate, then becomes x to the n plus 1 divided by n plus 1.
Morning.
And good morning. And then we said that a very important rule of the integration is when we have x to the negative 1. Only when we have x to the negative 1, we're going to be introducing the natural logarithm function. Only when we have x to the negative 1, we're going to introduce the natural logarithm function. Sir, what is a natural logarithm function? That is a function that contains ln x. See, I'm highlighting. Only when the function is raised to the negative 1 that we will have the ln function comes into play. So, sir, you're saying to me then that if you have x to the minus 2, it won't happen? That's exactly what I'm saying. Only when you have x to the minus 1 or 1 over x, same difference. X to the minus 1 is equal to 1 over x, all right? X to the minus 1 is the same thing as 1 over x. And only when you have that function, it is that you're going to be having, when you integrate it, you're going to have the natural logarithm function, the ln function. If you can't take the negative of a logarithm, so if the value that you're talking about is a negative value, then the answer is going to become the absolute value of x, because only positive numbers have logarithms. So you're going to have the natural logarithm of x, the absolute value of x right here. So this and this are the same. So that this one here is greater than 0, and the one here so is really it being less than 0. right? So when this is less than 0, well, let me put it back as equal to 0 there.
Sound like the market people and mash up, man.
No man, I don't reach market today, because I had a very late day last night. I finished class after 9 o'clock.
But after 9 o'clock, sir. At 2 o'clock, about 2 o'clock every night, me end up to go to bed, sir.
No, you make the money, me not teach.
Which money, sir? You know, see, assignment and schoolwork, brother. What did I? Oh.
All right, let us move. So we're looking at the integral now of an exponential function. Now, what it is that we do here, we say the integral of e to the x is e to the x, but we're going to differentiate the function up top and then reciprocate it. So the differential of kx is just going to be k. We reciprocate it and get 1 over k and then write back this function. So this e to the kx is the same thing as e to the kx. So remember, the differential of e to the x is e to the x. The integral of e to the x is e to the x. But let me just say that nicer. The differential of e to the x, and both groups, calculus 1, calculus 2, and business calculus would have done this already. The differential of e to the x is e to the x. But what we do, we differentiate the function and then put it back beside e to the x when we're doing this stuff. When we're integrating, the integral of e to the x is also e to the x, but we're going to differentiate the function and then reciprocate our answer. So the reciprocal of the differential of here is this 1 over k. Why, sir? Because when I differentiate kx, I'm going to get k, and then I'm going to put 1 over k. Why I had to do that? Because remember that integration is reverse of differentiation. Now, when I differentiate this, I will get back this. Let us try differentiating this. When we differentiate here, we're going to say the first times the derivative, because this will be a product, the first times the derivative of the second plus the second times the derivative of the first. The first times the derivative of the second will be the derivative of k to the x. E to the kx is going to be k e to the kx. Now k times 1 over k is just 1. So all I'm going to have is e to the kx, which is this e to the kx. But sir, you know the second part here, the second times the derivative of the first. The derivative of this first is a 0 because it's a constant, right? So I get back this. So I know that this is correct. All right. I want you to pay attention to this, because the law put this business here on exam, the exponential function.
Sir, I hear your eloquence in how you are explaining. Well, let me just say, you see, when you explain this, when you reach the point where you're going to be doing a problem with it, please point me back to this rule, and so I can then dissect it properly. I'm looking at that. I'm hearing what you're saying, trying to follow, but for some reason, if I'm not seeing numbers and stuff, it nah click.
All I'm doing is just going back through the laws, because remember,
I know. I got you.
Yeah. And then now for this one here, it says that when I'm integrating a constant with a function, we can haul out the constant. See here, take this and put it out here, so right here, so
yeah.
And then just integrate the function. And when we don't integrate the function, we just use this and just distribute it over the stuff. That's all it is saying. I want you to read up here, so. And number 7 here is saying when we do this is like a chain rule in differentiation. One function plus another function, or one function minus another function, is just individual functions that you're integrating at a time. All right. And
now, man, go through 8, man. Go through 8, man. Don't rush fast.
This one is just like this one. This one is just like the constant one. All right. When I pull out the constant out here, I can call -1 as a constant, and I'm pulling it out. See right here, so. And then I'm just integrating this function right here. All right. So that's just a quick review of what it is that we did last class in terms of looking at the rules of integration. As I said before, I've only highlighted 8 rules. There are additional rules out there, but your syllabus does not call for it. So I don't want anybody to say that, oh, there are just 8 rules for integration. No. They have we call it no.
Sir, that's a big school, Mats.
right? You have integration by parts. The first times the integral of the second minus the integral of the differential of the first times the second, then big something there. So you have whole heap of stuff. So, but the point I'm making is I don't want anybody to think that because sir is only giving you 8 rules, it means only 8 of them. What I want you to think is that sir only given product rule, quotient rule, and chain rule. Yeah, at them that one alone will have the differentiation, right? And in the mix of all of that, we have a power rule coming out, right? So we can consider it as 4 different rules and only 4. But for integration, many more, right? All right. So for both groups last time, I don't think I did this one with you. Let me just go through this again because what I did with my business calculus, and for those of you who are just joining, I sent an invitation out to the business calculus students to join. I think there's just one business calculus student here. That is just Joan. The others, me, not that. Yeah, are not here. It's just Joan. All right, Joan, you can come and shine over the rest of them. Come next week Tuesday here, pumpkin. So you try to make sure you catch everything. So what I did was just to use this question that I did with you on Saturday last week, but I'm going to go through the additional questions now and show you where I want to get you, and so we can move on to the other stuff. The aim is to finish integration today. The aim is to finish integration today. I have to finish the integration with your calculus 2 students today, and I'm hoping that while I complete the integration with you, I will be able to complete the integration with I'm seeing one more student joining the class, business calculus students joining the class. I can get a head start with it with the students. Time is really running. Had to consult my class last night because the man them just now complete the work on Edico, and I'll talk to you about that before we end. And yes, sir.
So, I know what me are talking about, I'm tell you.
Well, I know. Go
Peter
easy,
Gay,
no man. Go
Peter
easy,
Gay,
no
I know
Peter
call my
Gay.
name.
Peter
All I
Gay.
do is
know what
just
that
throw,
mean.
me throw me con,
Sir,
me con,
I'm
not
not on
a
the
phone.
computer, me and somebody the starters at work, but showing other girls, she's sick at work. So, and she the one, so
We
me
don't
I
want
tell
yeah, no
everything.
excuse, yo. No excuse.
Me I tell
Sorry.
everything.
Come here, me
Everton,
see
you
a
start
dream weekend
Everton.
party, you know. You can't tell me
Everton,
nothing.
you
Kimmy, can you unmute for me, Kimmy, please?
Sir.
Yes,
No,
Sir,
sir.
me see a
hold
dream
on.
weekend, you know, sir.
Hold on. Kimmy,
Yes,
are you hearing your handsome teacher, Kimmy?
Yes,
Just say
sir.
yes.
Lies,
Okay, good.
lies.
Kimmy, did you hear me call anybody's name while I was Kimmy?
No, sir.
Okay, thank you, Kimmy. You can mute now.
I'm
Peter, I don't know what.
I'm here to your weapon, sir. Come on, answer, come no say. I mean.
All right. But
Come here.
the truth of the matter though is we have 2 weeks because they said that the exam is going to begin on the 30th of August.
No,
So,
that no matter we, sir. So not our exam. So that means we're gonna still have you until the 8th.
your exam is on the 8th? If that is
No.
the case, that's it. Right.
No, it's the 9th.
The exam is the 9th. Okay, good. Christopher or Joan, do you know when exactly the business calculus exam is going to be on? The day? You can check it for me, please, one of the 2 of you, since you're here.
So, sir.
I think it's the 6th, sir.
It's the 6th. Thanks, Joan.
So that means I will still have time. So what I go on is that once we know say you have exams and exam them done, you just have to keep class with 3 times a week.
But you see, what you must remember, you know, it is very difficult for me to conduct a class when exam has started because students are doing multiple courses. I may say, okay, we're meeting Tuesday, and then the whole class will say, sir, Tuesday we all have an exam. So it is very difficult. So I will
if
have
you can't
class.
come, you can't come. If you can't come, you can't come.
No, that's selfish. But I
don't
can
matter
do.
Selfish, sir.
We can do it on a Saturday, right? And maybe not necessarily in the week. But anyhow, the point I'm making is, guys, we don't have much time. Time is of the essence. All right, let's go. So the aim is to go through as much of the differentiation as we can go through as possible. For the business calculus students, you are seeing on the screen here mean value theorem. That's not on your syllabus. I have some that's the mean value theorem. I have mean value theorem. Yeah. So these areas on the stuff, not for you business calculus students, but what I can do for you, I can either create a a breakout room for those of you who are here and give you, and the trapezoidal rule is not for you either. I can create a breakout room and give you some additional work to do so that you can do the stuff, or you can sit in a group here and I can project work for you. So it is that you can get some stuff done up today. And when time would have expired, we just say our goodbyes. All right. So having gone through the rules again, allow me to do
Sir,
some questions with you.
one last question. What is the name of this thing again, sir?
Integration.
No. There's another part of another name. Don't say integration. Antiderivative. Okay, thank you, sir.
So you'll hear me say antiderivative and integration. All right. So look at what is happening, and I want you to work with me with this particular question. And I'm going to be generating a few more questions so as to give both groups an opportunity to get some stuff done up. Work with me. I'm asking you to find the integral. When you see this elongated S, it means that is the sign of integration. So let me read what this is saying. I am to integrate the function 1 over x squared with respect to x. I couldn't put dr right here, so because this is not an r. If I had dr here, that means it would have been 1 over r squared. So this here tells me the variables inside of here. This here tells me that if I have an r here, that the r is going to be a constant. All right. So and when I move into multivariable functions that the business calculus students will also be doing, you will see more of that because we have to do some integration of multivariable functions also. All right. What we're doing now is integration of single variable function, meaning so only one variable in the function. All right. So let's go. So I'm integrating this function and it's an indefinite integral. So how do you know that it's an indefinite integral? Because there's no upper limit, neither there is a lower limit. All right. So I'm going to be rearranging the function. Why am I rearranging? I'm rearranging sentences that I don't have to use. It's easier when you rearrange. It's really very easy, much easier when you rearrange. Because remember, when you integrate, all you're doing is adding 1 to the power and dividing by the new power. In this form, you can't just go ahead and add 1 to the power. And you can't use no quotient rule because this is not differentiation. So it is always very useful to rearrange. All right. And then now, when I rearrange, I'm going to remember the laws of indices. I'm going to have x to the minus 2. I'm going to have x to the minus 2.
Yeah, wait for it, recall. Magic. All right. They say indefinite function. Indefinite.
Indefinite integral.
Indefinite integral. Sir. You see the video with the lady, where the people in the yard that they want a party and police are pass and everybody are bend down.
Yes, I saw that behind the zinc fence.
Yeah.
Is it gate? Yeah.
One lady, one girl where I want help for some people, them see her and them fire.
Oh no.
She in a video bend down and them see her.
Oh no.
And fire. And I want old lady, she take care of it,
Yeah, she's irresponsible.
I say, oh God. Yeah, look out for you too, sir. I never see.
Virginia, I want to maybe go on party,
Sir, stop it. Sir.
All right, trust me. Look at this here. Look at this recall here. Rearrange to give. So
Integration, antiderivative.
okay, so guess what?
Derivative.
My recall is at the wrong place. All right, so I'm recalling a to the negative m. I should put this the other way around. No, make it safe. We're not big school people.
No, not do that. If you
1
feel
over
it,
8.
go.
The same difference. There's an equal sign, and the equal sign can be read either way.
Okay.
1 over a to the m is equal to a to the minus m, or a to the minus m is equal to 1 over a to the m. Right?
Same thing
So
as 1 over anything.
a to the positive m is the same thing as a to the negative m. All right. So this here, you can say that this is 1 over a to the positive m. And then now, when I transform it or rearrange it, I'm going to get a to the negative m, which is x to the minus 2. So I'm taking this positive 2 here. I'm taking everything in the denominator into the numerator, and then the power becomes negative. See here, a to the m is 1 over a to the m. And when everything goes into the numerator, it becomes a to the negative m.
Oh, so once it goes into the numerator, it changes.
It changes. So what it is that I'm doing, I'm actually reciprocating, we're down here so, we put up here so, and we're up here so, and put down here so. So there's an imaginary 1 here, but I don't have to write it because when I divide anything by 1, I get back the same thing. True or false?
Well, listen to you.
Yeah, man. Alton, I really hope that you're with your teacher this morning. All right. So now remember again the rule that says I'm adding 1 to the power, I'm dividing by the new power. I'm adding 1 to the power and dividing by the new power. I don't like when I write it like that. I prefer it this way. I'm adding 1 to the power and dividing by the new power. So I'm adding 1 to negative 2, it becomes negative 1. And I'm dividing by negative 1, and I have my plus c. And negative 1 divided by all of that is just a negative x to the negative 1. But using this law, a to the negative m, x to the negative 1 is really just 1 over x. So that's why I get this 1 over x plus c. And this is my answer.
Go on again, sir. Make that sink in. Go on again.
All right. So let's go again.
Sir, the one where I divide by a while ago just become negative. If it is positive up there, you're not adding.
A negative times a positive is equal to a negative.
No, but that not only that. Remember, I'm dividing by a negative. You say, look here, Christopher. I'm adding 1 to the power, and then I'm dividing by the new power. I'm adding, right. So this is negative 2 plus 1 is a negative 1.
Oh, yeah.
Is that Chris?
Yeah.
You know, see Chris.
All right.
Look,
you know, see it. You know, see it. Hold on. Hold on there, Papa. Look here. Let me just try something here and show you.
The opposite when you do something there, when you do what the other one, the derivative. Remember with the derivative, you're minus 1 with the power. You're minus 1 from the power. So with this now, you just add 1 to the power. So 1 plus negative 2, I'll give you a negative 1.
I'll give you a negative 1.
Yeah.
But the rule said that you divide by the power that you add to the.
No. You divide by the new power.
You divide by the new power.
Okay.
New power. So you see it's the n plus 1. So whatever at the top. Yeah. You hear me on fire now, sir? You hear me on fire now, sir?
Very good.
You know what going on?
Anything you get again?
Wait until 11 o'clock when the birds start shut down.
Wait, no. I mean to tell you, as I'm Easter, I'm gonna drink a while ago, and my brain on fire.
Peter, you're mean. All right, let's go. Chris, look at this. Not just Chris, but I want the rest of you to look at it. Okay, welcome, Emilius. I'm seeing 4 of my business calculus students. Welcome.
They are good little while now, sir. For instance, just not say nothing.
No problem. No, man. The calculus 2 students know some of there, because I told them about it this morning, and them welcoming you guys. So if you have a question, don't believe that because it's not your class, you can't ask a question. Them not stay, so them are good set of people.
So you know me not, sir, I'm not saying that nobody in there. You know that already.
You guys such a Taliban. Welcome, Marie. Welcome. All right. So the guys are coming in one by one. All right, let's go. Today is going to be a class where we have a lot of hands-on calculation to do because you must get this. Similar to me doing stationary points with you business calculus students. If you don't know how to differentiate, stationary point becomes very difficult. If you know how to differentiate, stationary points is easy. And for both groups, calculus 2 and business calculus students, when you understand integration, everything else comes easy. And for the calculus 2 students, the other things, trapezoidal and mean value theorem and the whole other applications to the integration becomes so much easier. So you have to understand what is happening here. And once you do, you're good to go. So Chris, so this is what we do. So, and I want to say this because I want all of you to catch it. And I'm depending on those of you business class students here to take it back to class. This n+1, when I'm integrating, I'm adding 1 to the power. This new power, I'm going to be using it to divide everything by it. So it's adding 1 to the power and then dividing by the new power. Dividing by the new power. So look here, -2 plus 1 is going to be -1. That's why I have the -1 here. And that's why I have the -1 down here. Now, when I divide by a -1, it means that the whole fraction becomes negative, which is here. And then recalling from up here, a to the -m is equal to 1 over a to the positive m. I keep saying, in mathematics, we are so positive thinking that we don't normally write our final answer with a negative power. We always convert our answers from being a negative power to something that is positive, right? So always try to reconvert your negative answers into a positive power, which is why I went back and reconverted the stuff from x to the -1 to 1 over x to the positive 1. All right, so that's what it is. It's not difficult. And I'm saying to you, don't be fearful. I did this question with you, but I will go through the question again. I did this question with both of you. I don't remember doing this question with the business calculus students. I jumped out. So let us just go through this one pretty quickly because both groups would have seen the response or the question here. It says to integrate 3x cubed minus 2x to the 4th plus 7x minus 2. And you can just check the rules as you are going through this stuff by yourself. What I'm saying to you is, I have this function, and for you to understand the whole business of the integration, you know, this one just had one term, the one it just had one term. This one has multiple terms. So one with the one term, you just do it, broops, and you get the answer. All right. The multiple terms now, I'm going to be explaining what it is that we're doing. With the multiple terms, all I'm doing here really is just, and I did something nice with the business calculus students, and I need to copy from their worksheet and put over here. What I'm doing right here is integrating this piece, see it right here, so. Then I integrate this piece, see it right here, so. Then I'm integrating this piece, see it right here, so. Then I'm integrating that piece, see it right here, so. In explaining to the business calculus students, I did something very nice, I believe, in explaining what is happening, and just allow me to go into their integration. Into their
Before
notes.
you stick up in, sir, just scroll back down a little bit so we can screenshot the first something so we can, please and thanks.
Come in, honey. Let me just do something here with you. Let me just do something here first with you. Copy.
Sir, I don't know,
Yes,
sir,
sir.
but what you say you integrate it. All I see you do is just make sure say you multiply out back this ugly thing will look like one S over go right cross, correct? Oh, why move it? Oh, am I just
no, hold on. I did this with the business calculus students, and I think it's a good way to really explain all that is happening. So let me just go back here. This is where you want me to copy it again, or the first one up here?
Yes, sir. Let me screenshot it quick.
All right,
I can move it now. You can go ahead.
All right, Everton, you're saying that what are you? Yeah. So technically, you know what?
You just move the bracket. You just move the bracket. Sir.
Yeah, I'll come into you, Papa. I'll come into you.
Sir, no, but I move it in a car. I think me look like me I make some sense with it in a sir.
I think I need to move it. I think I need to move it and put this one as number 3. And put that one as number 3. I think I need to move it. I will explain why I'm moving it. I think I need to explain it this way first, and then I come back to number 3. And then I come back to that one. I was in class on Thursday, introducing this to the business calculus students, and it just dawned upon me that I should just show them this way. So let me show you this way first, and then I'll come back to that one. So we're doing this question. This question is 4x to the fifth plus 7x cubed minus 6x squared plus x minus 9 dx. What this is saying, what this is saying is that I'm integrating all of this. Remember, this elongated s means to integrate. So I'm integrating all of this, all of here, with respect to x. It means that the variables, all the variables inside of here contains some x, to the point where I am now going to put something in there, business calculus students, that I didn't have for you, just to bring across another point. And you see, it's one of the things. Every time I go back to the document and look at something, another idea comes to mind, and I improve on the document. So watch me. I'm putting x to the 0 here, just to bring across this point. You know I don't have to put x to the 0 because you know anything raised to the power 0 is
0.
no. Anything raised to the power 0 is
1.
Right.
Do we any mixer, Russia?
Should we get used to anything?
Morning, sir.
Good morning. Who said good morning a while ago? Yes, Philly. How you do? Welcome. Welcome. All right. So, hold on. All right, Philly. Welcome. All right. So let me just say something. Philly, you haven't really missed much. I did a review of the rules of integration that I did with you on Thursday. And I went through this question that I didn't do with you guys, but you should have this in the, you don't have the handout yet because I was supposed to update something that I don't do yet.
I was just going to say that. Remember to send the handout when this class finishes.
When this class finishes, yeah. So what I'll do, I'll just copy the stuff from this class and send off to the BizCal students, since I'm going to add a whole lot more questions to this. I did not do this question with you, BizCal. I just went through this a while ago. Okay. This one I generated in class, business calculus, and did the explanation to it. And I just thought to myself that I should do the explanation this way first before I go to here, because I'm actually skipping out some stuff here, but I just wanted to get the foundation, like from first principles, then go here, and then when I move from here now, I go to where I want you. Because where I really want to get you guys is to get the function to integrate. Boom, one shot, just integrate it. You see all of them right up inside of here, sir? I don't want to see it. What are you saying, sir? I am saying to you that because I am now introducing the integration to you, I am going through step by step. I don't want Everton bringing more to me, so I am going through step by step. Now, after this example, you will see me reducing some of the steps because I would expect you to get it from here. And then after this example now, we're going to hold the big school people to the question. You get this, you do that. 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 Bam, you're finished. This is how they expect you to do it in the exam. Then what if I write up here? No, it is because I'm teaching you. And I have no problems doing it because I really want you to get it from the first go. So let's go.
And anyway, you get it, so you have to take it once my answer right, you know. That
well, I mean, and I mean,
if
I mean, if you the aim of the thing, you know, is to get your answer to be right. So once your answer right, kudos. All right, let's go. So I'm integrating 4x to the fifth plus 7x cubed minus 6x squared plus x minus 9. Sir, why did you put x to the 0? To show you that this dx is telling me that everything contained in the parentheses has some x in there. So the 9 here, that this negative 9 that stood by itself is not 9p or q or r or s or t. It has to be x. It has to be x. But x with a 0, because you know anything raised to the power 0 is 1. All right, Peter Gay? Anything raised to the power 0 is 1. So what this is saying, to me, I have 1, 2, 3, 4, 5 terms in this integral. I have 5 terms in that integral. It means that I'm doing 5 individual integration. Watch me. The piece here is this. The piece here is this. The piece here is this. You notice I have a plus sign here, so some students in the BizCal was asking, say, why never put the minus sign out here? No, because I'm showing you that I'm integrating individual pieces. So this piece that I'm integrating, I'm really integrating negative 6x squared, not just 6x squared, because the function, this term is a negative 6x squared. So I'm integrating negative 6x squared dx. Then I'm going to be integrating x. Then I'm going to be integrating negative 9. So instead of dx here, and a dx here, and a dx here, and a 1 here, and another one right here, so is this dx, because this dx is multiplying all the 5 terms inside of here. So that's what it means. All right. So now that you see this, what it says to me now is that I must integrate these terms individually. And what I tried to do was to put it in, was to color code it. Now, time was against me in class the other day, so I never got the chance to color code the others. I am doing that now because I really want you guys to see what is happening. That is purple. I really want you guys to see what is happening because that's what, hard, It is just that a lot of students not doing the application, and the other one is what? The other one is blue. And I really want you to see the application of what is happening here. No, I said blue, not green. All right, so watch me now. So I'm doing the color, I've done the color coding, so it is that you can see what is happening here. So in this first term, watch me. Those of you who are distracted, ask the distraction to just press pause. Right here, so the rule says I can take out this 4 because it's a constant and fling it in front of the integration sign and just be left with my x to the 5th dx. Everybody see that?
Yes, sir.
All right, good. Make sure to see it, work with me. Work with me. I'll leave my signs out. This one here, the integral of 7x cubed dx, what it's saying to me, based on the laws that I presented, what it is saying to me is, I can take the 7 out in front of the integration sign right here, so. And then I can go ahead and integrate my x cubed dx. The last law right here, so, says to me that this negative of the function, I can just take out the negative sign and then integrate the function. It's the same thing that I'm doing. I'm taking out the negative sign right here, so bam. But I recognize that 6 can be taken out, just like what I took out the 7 and the 4. So I'm just going to take out the negative 6x, the negative 6, I'm sorry. So the negative 6 comes out, then I'm going to be left with x squared dx. Oh, but sir, me not see nothing for take out right there. So okay, fine, see it, you leave it alone. Me see it, because me see 1 right there, so, but you not see it, leave it alone right here, so. This negative 9 can be taken out just as though I took out this negative 6. And then I'm going to be left with dx. Is there an imaginary 1 right here, so? Is there an imaginary 1 right there? See it? The integral of 1 written simply as dx, not 1 dx. Don't you know how 1 is right here, so?
Yes, sir.
Good. So we're not going to write 1 dx, we're just going to write dx. That's what the rule says. So that's exactly what we're doing. So there's a 1 here, but we're not going to write it. All right? So I have moved from this line to this line, and I've color coded it so it is that you can see what is happening. Now we are going to be integrating. So I can say no. Sorry. No, we are going to integrate. REMEMB. Remember that we add 1 to the power and then divide by the new power. I want to tell you that we start the integration now. So now we are going to integrate. You see, when we integrate, this elongated s is removed. So this elongated s tells me that I'm integrating. Once I've integrated, I'm going to remove it. You know why? If I don't remove it, it means I'm going to integrate it again. And that's why business calculus are putting something here in here. Not that I didn't tell you, but I want to put it so it is that you can see. Now we are integrating. Remember that we add 1 to the power and divide by the new power. It's very important, Just as, this is as important as the first times the differentiation of the second, plus the second times the differentiation of the first. It is as important as the denominator times the differentiation of the numerator. minus the numerator times the differentiation of the denominator all over the denominator squared. You're adding 1 to the power, dividing by the new power when it is that you're integrating. You're adding 1 to the power, dividing by the new power when you're integrating. It's very important. And if you can follow my lead, students, all of them something where to come like 1, 2, 3 now. All right, I'm purposefully taking a 1 minute break. I know we have done enough. And this 1 minute, I'm just going to be speaking about some stuff that I just want to listen, and then I go back to the stuff. Hear me out. I'm trying to make this a little easier for you. When we're integrating, we're adding 1 to the power, and then we're going to be dividing by the new power. When we're integrating, we're adding 1 to the power, and then we're going to be dividing by that new power. Remember also, which is very important, one of the other important conditions to integration, that when we're integrating and we would have rearranged our function, once it is that we have x to the -1, that is when you're going to have the ln function come up. Only then will you have the ln function. And I'm going to give you a question next on that. All right? Only then will you have the ln function. But what is very important is the integration of when you're integrating, you're adding 1 to the power, and then you're dividing by the new power. If you don't leave with anything else to the class today, leave with that, because once you leave with that, it means you understand the integration. All right, going back now. So this 4 is this. I am now integrating x to the 5th. The rule says you add in 1 to the power and dividing by the new power. Power are the something with the on top. Base are the something with the on yaso. So I'm adding 1 to the power. 5 plus 1 is 6. So this becomes x to the 6 divided by 6. See it right here, so. But sir, this is an indefinite integral. That means I must have my plus c. See it right here, so. Okay, sir, got you. So this term is done. This is this. This 7 is this 7 here. Because the question says, the rule says, I can factor out the constant, and then when I finish to the integration, I just multiply the constant back into the something then. All right? I'm integrating x cubed. When I integrate x cubed, I'm adding 1 to the power, divided by the new power. Lord Jesus, I sound like a broken record. But I like sounding like a broken record because this is the truth. Add 1 to the power, divided by the new power. Add 1 to the power, divided by the new power. I'm adding 1 to 3, I get 4. So it's going to become x to the 4th divided by 4. See it right here, sir? X to the 4th divided by 4. Plus c. So you have to put a plus c? Absolutely. Why, sir? Because it's an indefinite integral. Okay, sir, got you. This minus 6 is this minus 6 right here, sir. Then the integration sign tells me that I'm supposed to be integrating this x squared with respect to x. Not a problem, sir. Remember, we add 1 to the power and then divide by the new power. So I'm going to add 1 to 2 to get 3. So it's going to become x cubed divided by 3. See here? X cubed divided by 3. And because it's indefinite, I must have my plus c. Similarly, I have my, oh no, sir. Let me just put something right here. So to show you, because I don't want anybody to miss it. When I write x,
where I gotta put the 1, right?
Right.
Oh.
So just remember, be ye reminded that there is a 1 up here. So matter of fact, let me see like that. There's a 1 there. All right. So when I'm adding 1 to the power, don't say the x and say that there's a 0. So you add 1 and just get 1. No, there's a 1 there. All right. So I'm adding 1 to the power. So it's going to be 1 plus 1 is 2 divided by a new power. See there? X squared over 2. And then I have my plus c. This -9 is here. When I integrate dx, I'm going to get x. See here? When I integrate dx, I get x plus c. So that's why I get this times x plus c. And then now, let me just, all right, cut. I want to put something here. I know I did it like that with the other group, but I just want to fix it up here. So paste. All right. So now, so the integration is finished. All right. And what I've done here is to show you that instead of green C here, other one here, or rock zone, or this is orange. This orange C is this one. The black C is this, the purple C is this, and the blue C here is that C. Now, when I have this C plus this C plus this C plus this C plus this C gives me another C. Because a constant plus a constant plus a constant plus a constant plus a constant is a constant. 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. And 15 is still a constant. So all of these here is just a constant, right? So in writing this, in simplifying this answer here, look at what I'm going to be doing. Let me see if I can code. In simplifying that answer, remember they say to you that the 4 is going to be multiplied by everything here. So I'm going to have now 4x to the 6 over 6. See it right here, sir? 4x to the 6 over 6. You notice I take off this little c, because a little c here plus a little c here plus a c here plus a c here plus a c here just give me this c. And this c that I have here is this c now. So all those little c's form into this c. Then, sir, what if they write back a little c at the end? I would get it right? Yeah. But for the purposes of showing you that all these little c's give me a big C, is just to show you that these added to give me this one c. So if you want to write as your answer a little c right here, so for the final answer, it's neither here nor there to me. But just make sure that you have this constants of integration, or else you lose a mark. All right? And then now this 7 times x to the 4th over 4 is 7x to the 4th over 4 minus 6x to the 3rd over 3 plus x over 2, x squared over 2 minus 9x plus my constant there, c. And all I'm doing here for the final answer is just simplifying. 2 into 4 goes 2 times, 2 into 6 goes 3, so this becomes 2/3 x to the 6, or you can say it another way, 2x to the 6 over 3. I can't do anything to this one, so I write it back. This one can be simplified further. 3 into itself 1 and 3 into 6 goes 2 times. So this becomes 2x cubed right here. Can't do anything with this one, so I leave it alone. Can't do anything with this one, leave it alone. And this is my final answer, right? This is my final answer. Now, now, copy. Copy. I am showing you something here. What? What am I doing about it? All right, undo, 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 undo. I copied the wrong thing. Undo. That's what I need to copy. Copy. All right, so I'm checking my answer. I'm checking my answer. I'm checking my answer. And I want to work with it. This part is very important. I'm checking my answer. And this is where I want to get you guys. Remember I said to you, I already did all of this, drawn out something here. But let me not call it drawn out. I did this here just to, as I'm explaining, right, as I'm explaining the stuff. But this is where I want to get you. By the end of the class, this is where I'm going to get you. You're going to look at the question right here, so. I'm going to do the question right here, so. Watch me. The rule, the main rule is adding 1 to the power, dividing by the new power. Watch me. Copy. Paste. Bam. So I'm adding 1. I put this here because, this is what it's going to work out to be. I'm adding 1 to the power and divided by the new power. Watch me. 4x to the 6 over 6. See here? 4x to the 6 over 6. Plus 7x to the 4th over 4. 7x to the 4th over 4. So I'm showing you that it can be done in one sitting. Negative 6x to the 3rd, sir, over 3. Negative 6x to the 3rd over 3. X squared over 2. X squared over 2. minus 9x, sir, minus 9x. And then I simplify this to get this. So I don't have to go through all of this long sum. You can do it in 2 lines. You can write it as it is here, and then you can simplify it. And which is what you see me do. Write it as a whole, and then simplify it. Now, let us try this one. Let us try this one this way.
Sir, so we could write it like that in the exam then?
Absolutely. 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 Is what I want to call this check. C-H-E-C-K.
Don't trust him, you know, because based on how him feel, how much work you do in class, or your participation. Yeah. Yeah.
No, man. Trust me, man. That's my check. And I want you to to believe me. Don't follow the button here. Believe me. No, I want that. No, I don't want it like that, you know. C-H-E-C-K. And then that. All right. So that's my check. All right. So let's go. So all of this is here, you know. All of this is here. But let me go to where I want to get you. The integral of okay.
3x raised to the power of 4 divided by 4.
No, this one I don't have to. This one I don't have anything to simplify, so I can just leave that out and just put it like that. All right, so let's go. I am, and that's correct, Lou Everton, very good. So I'm integrating, so I'm adding 1 to the power divided by the new power. You see all of them stories I'm going to tell you? Just recite them now. You're good to go, you know. We're doing integration, or integration is adding 1 to the power divided by the new power. Here's the story. 3x to the 4th over 4. Sir, how come? Remember, you add 1 to the power divided by the new power. 3x to the 4th over 4. See that? 3x to the 4th over 4. And the minus sign, the right hand side. 2x to the 5th over 5. See that? 2x to the 5th over 5. 7x squared over 2, sir. 7x squared over 2. Minus 2x. Minus 2x. Plus my c. Now you tell me, look at this. This here, I don't have to do all of this. I only did this because I wanted you to see and understand where we're coming from. Where I want to get you is moving from here directly to here. This question is about a 5 marker. 1, 2, 3, a 4 marker. 1 mark, 2 marks, 3 marks, 4 marks. If you have
so the C is a mark, you know, I'm to the
no.
C. So
you
if I leave off the C, I now get it right there. May I get it right?
If you leave off the C, you only get 3 marks.
So may I talk about?
Yeah, but man. You have to have the C because the C is a constant of integration. It must be there. And you're integrating an indefinite integral. So if you have all these 5 things, 1, 2, 3, 4, 5, you get your 4 marks. If this is missing, I take him back 1 of the marks. All right. So that's exactly what it is. Let us look at question 2. Let us look at question 3. Question 4, I'm sorry. And I'm going to give you a few to do in class. No. I'm integrating 5x to the 4th plus all of this plus all of that. I'm integrating. I'm adding 1 to the power divided by the new power. This becomes 5x to the 5th over 5. Oh, sir, but we don't see that there, so no problem. Copy. Paste. And 3x squared over 3. X squared over 2. No. Yeah. No, this is just x. All right, watch me. So this is going to be 5x to the 4th. I'm integrating 5x to the 4th becomes 5x to the 5th over 5. See here? 5x to the 5th over 5. This is going to be x to the 3, x to the 4th over 4, x to the 4th over 4. This is going to become 2x squared over 2. X squared over 2. And this is just simply x, and then I have my plus c. 5 over 5 cancels, it's only left with x to the 5th. X to the 4th over 4 is this. 2 cancel with this 2, so it only left with the x squared, which is that. This x is this, and that c is that. And it's done. Finito. Tell me, is this difficult?
Now that
Yes,
you have
sir.
taken the time to elaborate and use a certain level of eloquence in your explanation, it's not that hard, sir.
All right. Thank you, sir. 6. 9. Is that 5? 1, 2, 3, 4, 5. All right. I'm gonna give you a few to do for me.
Sorry, you say the show was the negative.
Yeah, man, I'm going to, honey.
Sir, I feel like Shanice will get like 100% in a sir for some reason, you know.
And Shanice knows what is at stake.
Yeah, look now, it's Shanice quiet and not say nothing too tough.
No, man, she knows what is at stake. She knows, say, a fear here, the area. And our first paycheck, me and her go, no, we're not going to friend because COVID up there.
No,
we are
yeah, right.
We are going to my food, don't Shanice?
Shanice, buy something for somebody out her peer. You have to see this. Me have to see this.
Leave Shanice alone, man. Me and Shanice are going to eat a good food. To the 4th.
If I that sir, whenever want nothing too tough, want some curry chicken back on Irish and yeah, what we are talking about.
Oh, truth.
What do you man? That I have Shanice know for cook curry, come and she run my belly, you see it?
Hey, Shanice, I cook it, you know.
No, Shanice. What she said? What she said?
She said she's not going to dignify that with an answer because she knows she's a cookies.
Oh no, all right, but if you're not eat chicken, but just cook it, me eat it all like
and put on 2 slices of pear on that too, you know.
Oh God, man! I move you, I'm moving. Sir, you know, so I have a customer where I sell him house and I want lawyer and try put it on clause in the contract say he must be able for company property come pick pear off of the tree we plant when him about 25. Man about 60 something. Yeah, man, the people them look on him and tell him say more time mine.
Or him lift up the tree and carry it with him.
Him can't lift up the tree and carry it. The tree is huge, you know, man. It's a massive tree, you know.
All right. Look at that, guys. Trust me. All right, look at this, guys. I have these questions. This last one, I'm going to call it TRICKY because that's what I'm going to come in to talk about. Shanice, this is what you're asking about. So I want you to do these 4 for me now. I'm going to give you, this is 9:48. I'm going to give you 10 minutes. So start working for me, please. Yeah, I'm going to start working for me, please. You have 5 questions. Start working for me, please.
So 1 second, can you scroll up the one I did before? I just want to see something.
All right, okay. Let me just see something here. No, it not gonna work. So, all right. Just remember this stuff. Yeah, I didn't want to the power divide by the new power. All right. On the mark, get set, go. I'll give you 10 minutes. I'll soon come.
Sir, I'm going to drinking cocoa tea and 6. That's 1. That dx outside. This robust. That's x 10. Yeah, let me ask you something. When you have one is already one, so it's going to raise to the power of 2 over. Am I the right way that I did?
X. The one is going to be X.
All right, cool. So that means it's going to be, so it's going to be x squared over 2. All right, cool. That's...
Shanice,
Hi.
so this the x to the 0 was like in 1, right?
X to the 0 is 1, yeah.
Oh, all right.
Where is it at?
The number 9, when you have x to the 0, remember say when you add 1 to it, I get negative when I get 0. So x to the 0 wouldn't be 1 right here. So
X to the 0 is equal
X
to
to the
1.
negative 1?
I remember when you do the integration thing, remember so when you add 1 to
Negative 1?
0.
Yeah, it would be 0.
Yeah?
It wouldn't be 0 because I add.
Yeah, but when you add a negative, it come like say when you add
A 2
when you add
negative, yeah,
1 to
if
negative.
you add negative, or you mean plus 1, not added to negative 1 plus 1.
So
Yeah,
no
negative
0.
plus 1 is 0, yes.
So x to the 0, no 1.
Yes, it is 1.
All right.
all of them answer are gonna be plus C at the end, don't it?
Yes.
Mad. All right, I feel like I for ask for help now. So 8, right? With the 7. With the negative 7, right? The negative 7 is a constant. Cool. You just write that back because you know say it still means is x raised to the power 1. Correct? With the 7, correct?
7 is going to be 7x.
All right, 7x, cool. Now you raise that, so you're gonna end up with 7 square
No, you're not
divided by 2.
raise it.
Oh, you just gotta put back
With the
7x.
7, the 7 will be 7x, yeah.
Oh, Shanice. Totally. 1. 7x. But oh yeah, I can't. So just let's see. Let's push it by 1 by a 4. And then we have a self plus C. I won't I get them somewhere right there. All right. All right. So for the one, the last one, the plus one, or the last one was sir said tricky, right? I want to get for the last, for what the way I put for one. Me think me that raise the it's because it's a x, me I raise it to the come up to
One with the negative, raise to the negative 4 is going to be ln x.
yeah, none of that me talk. Me get the ln x part already. I know that part already.
The last one,
I thought the constant of the x.
just plus x.
Yeah.
The last one of
yeah,
x.
that's supposed to be the same thing.
You sure? Plus x?
What? Yeah.
Yeah, it is one.
That's
X
still one x.
Oh, it's plus x.
Mm-hmm.
Doing stupidness. Plus x. Damn it.
What is about ln x?
Yeah, remember say anything what raised to the power negative one, it'll go have a ln. You have to drop the ln in front of it.
Oh shit.
That's why I'm said tricky. But him there say it from class start last week. All right, so then I'm gonna go yes or no. 3 and that got 3. So that's about 3. 6x plus.
Now I have what? ln x?
Yeah. ln x plus x. Well, I know I'm gonna do some foolishness, but one of them up there saying once I one did it, I do it, it's supposed to just turn back to x. All right, for the foolishness that we do. It's supposed to be just x. Supposed to be x. When, sir, I go a mid-semester exam. Nobody know?
No. No, you never said set already. You figure out you're gonna get it when you're ready. I still can manage it.
What is? Okay. That's fair. So the constant always just comes back to x. So if at the end of number 6, so it's a 7, negative 7, we just have to put back 7x, right?
Yeah.
Mm-hmm.
X already is there. No, hold on. What may I try remember if him say even when the imaginary x is there and it is, you know, that is x to the 0, it still represents x to the 1. So yeah, true. All right, I got you. Comes to 1. All right. All right. So now makes sense. So now makes sense. I messed up.
Wanna see how the earthquake mash up here, see?
Which earthquake? More earthquake man again?
Where were you this morning?
Me?
Yes.
In dreamland. I dream about me I gotta get for left exit and you know, stop scam and all them things.
You know, I'll leave exit because I see it where you want the master exit. So I was saying master the next 2 years.
If we can get a master's for $700,000 versus $3 million in other places, I'm going to think about it. I'm not like you, I'm not rich and have multiple streams of income,
Oh, you know me have multiple streams of income. Oh, you
because of you name or your name.
That does say?
You're rich. I mean, plus you chap the line too. That's why you say I'm a boss.
One, yeah.
All right, so this is gonna be x then. It have to be x. A constant is equal to x. Correct? 1 is equal, and a constant is equal to x. That look like it makes some sense. That's all. So I don't really want. Can't believe me really I make a mistake here. Plus c. All right, okay, so sir say when him come back, and we come back and sit down and listen and answer nothing. Think him easy. .2. Are you serious? Yo, are we 80 doing in a one of the lifetime, brother? Bomba. Hold on. So Peter, can you put the picture of them in the group now? I see them.
My phone can't download not it full. I'm a camera delete nothing right now.
You're too hype,
You
man.
look in our group, you see one video.
You're too hype, man. I can board me for rich people, listen, man. So rich, you know. So rich too. Watch him a sneak in. Watch him.
I'm to you. I will trouble.
Sir, you're not telling us that 80 mash up, earthquake mash up 80, sir.
Yeah, man. I didn't say it. Yeah, man. I can send a video in the thing. Right. Jesus. It's rough. Let me say it's rough. It's really rough. Demolished buildings there.
Then they just barely recover from the massive one.
People died as well.
Yeah. It's
Sir,
rough.
say I go over 80 for the relief thing, sir.
Me? No, sir.
You see, you're there talk all of these things and bless the Lord with it and with him name, and you're not do the right thing, sir.
Oh, dear.
You need to go and do the right thing, sir. You need to help thy fellow brother, you know. I'm imploring you. I mean, now comes to the number.
Okay, so you know I'm not talking. All right, look at the first piece and tell me if you get that.
Sir. Oh, you get that now, sir.
No. Right. It's supposed to be x to the 10 over 10.
Yes, sir.
Yeah, where you
x to the 10
sir?
over 10. I don't know what I'm thinking about.
Wow.
X to the 10 over 10. Look at the answer now. The answer is x to the 10 over 10. Blow, Shanice.
Yes, sir.
You got true Shan. Shan says, sir, where you get that from, sir? No, sir. Yeah, man, very good. And I want to hear from the others of you, to make sure that, we're not following what teacher Shan said, because it's very important.
Top scammer. My gosh.
Yeah.
I have.
Yes, please. Yes,
sir,
yes, Steely.
Maybe kind of stuck at the third line.
No, man. And you know why? You know why you get a third line anymore? That's why you get the one-shot line. X squared over 2.
Sir, 2 line with the mining and so I can't follow.
And that's perfectly fine.
Well, because we do it first, let me just integrate it and then come down to the line. So it did take longer. The one-shot line thing for you kind of bossy, but my brain not works. So I need to see what I can look back on it and say, all right, that for good, so, you know. So
And
when
that's
I
fine.
study.
Sir,
Yes, please. Yes.
this
Yes,
number
please.
5, in the number 5 answer the 3x 4 over 2.
What, number 5?
Yeah,
Yes.
3x to the 4th over 2.
Yeah,
That's what
at
I
the
have.
end. Yeah.
That's
Oh,
what
you
I
put
have.
2 into 6.
Right.
Okay.
On a serious note, you know, people, see the bright people in my class. We want to see if we can line up and run a little marathon. You see it?
You've
I
been
know
asking
me.
that from last week, and I don't hear nobody take it on. All right, look at number 6. Are you in agreement with number 6?
Number 6. Let me see what my number 6 says.
Yes,
Yes,
sir.
Is
sir.
x over 11. Where number 6? Okay, yeah. 6, so x6, yeah. 3 raised to the power of 2, yeah. 7x, yeah. Yeah, man, sir. That look like it, right? Well, it look like it. You have what me have. So I don't know if
Sir,
it's a
don't
trick
move it yet.
question. I don't know if it's a
It's not
trick question, you do, sir. So you're
no, man. It's a real thing, that man.
So you have a tendency to do some little thing and make some mistake and then say you think we are looking at, sir.
Well, that part is true, but no, I tricky this morning. Oh no, I'm doing to the 3rd. All right, Feely. Look at number
Yes, sir.
7. Look at number 7 and tell me if you agree with that, please.
To the power of 6.
Get all of the second line so far.
Yeah.
Oh, you know, I understand. So me have to put back 5x 6 over 6.
Yes, sir.
Put back. Oh.
Very nice, very nice, very nice.
Just half of it, me get, sir. Half.
No.
Hold on now.
And guess what? You are much better than what you were doing on Thursday. So I'm happy that you're here.
Hey, sir, me get that. Me get 7 right, sir.
Very, very, very nice. Emilio, you're good, right?
Sir, quick question, sir.
Yes, Kimani.
Sir, supposedly put 1 in front of the x will stand by itself. That all right?
1 right, yes, sir? Or this, yes, sir?
Yes, sir.
Good to go. Full
All
marks. Emilio, how you stay? Marie, how you stay? Joan, how you stay?
You don't cheat.
Sir.
I come in, Marie. Ophelia, what you saying?
I noticed you don't change any of the signs, like where you have the minus, you put plus when you were doing some other.
No. Because remember, I tell you, say, you notice you don't see me have no 5 and 6 lines something.
Oh, yeah.
Because
Okay.
This is where I want to get you.
Okay.
When I did it, them times there was also explain what is happening.
Okay, sir.
In detail, in further, the rest of the explanation now you can have in your headspace and just shorten it and get it. This is where I want to get you. Marie, you're saying something, hon?
Yes, sir. I said I just get to log on, but because I was using my data and it chip up me out, so I kind of missed out on some.
All right, no problem. You'll see what is happening. You'll see if you can follow what is going on. Joan, yes. how you stay? And Alton, talk.
Yes, sir.
You stay all right, Joan?
Smoke.
Yes, sir.
Nice. Alton, talk to me one time in a class now, even one time, and let me know see how follow what going. Jeez, peace. Kimmy, you all right, Kimmy, sure? Kimmy, Sean?
Sir.
You're all right, don't?
Yes, sir. I'm okay. I got everything. I'm sorry.
Yeah, man. I know you're all right. I know you understand.
Wow.
Lando,
yes,
how you
sir. I'm here, sir.
And you understanding, Coco? Nice.
Yes, sir. I didn't have any problem with integration the last time.
Okay. All right. Great.
But at least everything is still coming back to memory.
Nice. I'm happy about that. Good. Peter G, how you stay?
Sir, I'm good now.
Very nice. And Shan, I hear you getting it, you know. So I think you have no problem. Shanice?
Yes, sir. I'm fine.
I know.
A valedictorian that no, you know, sir.
that.
That's easy, sir.
Alton, talk to me. Him just log on and talk about team business. He's on a Greater Portmore shopping center, run a supermarket, you know. All right. And Everton is catching it. All right, good. All right, so let's continue. I just have to check in to make sure that you guys are following what is happening. And we have the last 2 questions. Copy. We have the last 2 questions, and this is what I wanted. I love when I love when I teach and students get it. And you know the truth of the matter, guys. I don't ask you to be bright. Just be hardworking.
Sir, you're bright and you feel you're bright and going to exam and the exam kick with your foot thumping in your face until you do the circumference of the moon.
Absolutely. Absolutely. Absolutely.
I mean, seriously, maybe I get at least get a C- the last time. I swear. Mr. Shan. What you do, Mr. Shan?
You know, it's one of those things. Guess what happened to this question? I don't have nothing to simplify, so this one just went one line. Tell me if you agree with that.
Yes, sir.
That is what, 8?
Yes, sir.
Let me look at 8 said to me. Yeah, one shot me do it too.
Nice.
That, yeah. Negative. Yeah, plus C. Cool. Number 9 now with your ln function, each up in a top height.
Yeah, man, that one, yes, it nice.
So me get 8 half of me one.
What was that, Ophelia?
Sir, you put the ln plus x directly in it, or you
man,
you put it outside the bracket?
No, man, you put it
when
directly
you put in the ln x, sorry, in the Russell, you just put have like 1 over x for the last line.
You don't know. I soon tell you. Ophelia, you're saying something about
I said me get 8 without a problem.
Oh, hey, look, like me forgot put it on a Saturday morning.
It looks so great.
Me forgot put it on a Saturday morning. Nice.
Yes,
Nice. Just sleep and wake up, man.
Shanice, they are teacher class, you gone.
No man. I'm proud of you, man. Really, really very proud of you. Whoa, that one is nice, you know. Look on that one that tell me say on a habit lot.
Yes, sir. That's what
Yeah, man.
Wow. And then
hold on,
what's
6.
going on? 6.
They're gonna put ln x as 1 over x.
Sir, so you not simplify it, sir?
I'm gonna get it, sir.
Sir, so you not simplify that, sir? Oh, which is right. People dead.
Sir.
Sir,
Yes,
ln 1 over x.
No, because when I'm differentiating, I get that. Remember, remember, anytime I say x to the minus 1, remember this x to the minus 1 is 1 over x, you know. So when I'm integrating x to the minus 1, I'm going to get ln x. And when I integrate 1, I get x, and I have my plus c, and I integrate this, and we add 1 to the power divided by the new power. Add 1 to the power divided by the new power, I get that, and then I simplify this to get 3 halves.
So I get that part there, just the ln x part. So I put it over 1 over.
When you differentiate ln x, you get 1 over x.
Yeah.
Oh.
And 1 over x is the same thing as x to the minus a half. Very good, guys.
Odd.
Very good. You know why it's very good? Because
sir, you said when I differentiate
ln x, you get 1 over x.
So I put back 9.
When you differentiate ln x, you get 1 over x. Remember we did that already? For both groups, as a matter of fact, I did that for both groups.
You know,
so
I think I deserve a red stripe. I deserve a red stripe.
No. Next thing you go drink it away. No, keep it.
Deserve a red stripe.
Keep it going. All right, guys. Guess what? I'm very, 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 very encouraged. It's very good. It is very, very.
So you're not here, so when you're gone, Chinese a teacher class, sir.
Proud of one, man. Jesus. All right, I'm gonna move on from here. No, I didn't do this with the business calculus students, but it's not gonna hurt you. I was supposed to check something for them, so just pay attention to what is happening. By the time I reach class with you again, business cal on Tuesday, all being well, you will hear more about me. I needed to check your syllabus to see if this was on it, but I know it's on your syllabus. calculus 2. But business calculus, it won't hurt you to pay attention to this. For now, chances are it's there now, but it's just that I need to double check. And 2, it also helps you based on the question that Peter Gay just asked. Sir, you're not going to put 1 over x. So Peter Gay integrate it and then differentiate it. So this is where the differentiation comes in now of the logarithmic function. Watch me. It says if they give you a function like this to integrate, if they give you a function like that to integrate, copy. If they give you a function like that to integrate, best believe say x plus 1, that. Best believe that this is not difficult. Best believe that I can rewrite my function like that. Look at it. It's the same thing we have been doing. Remember, whenever you get the integration, always try to rearrange it in a form that it's easy for you to integrate.
Hold on. ln. Oh, okay, I get you. So because we have the -1 now, we just integrate it and put ln.
Yeah, because I mean, now you see the -1. Remember, the -1 is an indicator, that is ln function again, huh?
Yeah.
So now what it is that I have now, this is going to be ln x plus 1, and I just put it in the absolute value. Why did I put it in the absolute value? Because I don't know what the limits look like, and I don't want this come out to be negative, because remember I can't take the negative of a logarithm. So I just put it as absolute value. So in the event that x is less than 1, if x is less than 1, I don't end up with a negative value where the question can't work. So I just put it in absolute value form. Remember, absolute value says that I will never have a negative value. So the absolute value of -2 is +2. Let me say it again, because I know that just went by somebody's head a while ago. Let me go up here and show you something. So this is the ln function. And I'm saying, once it is that you see the -1, you know that the ln function comes into play. Excuse me. Sorry. Once you see the ln function, rubbish. Once you see the -1, anything raised to the -4, you know that is the ln function. All right. Now it says the condition x is greater than 0 is added because only positive numbers have logarithms. So we can't take the logarithm of a negative number. It does not exist. The logarithm of a negative number does not exist. Not today, tomorrow, or ever. Does not exist. So what I'm saying to you, because when it is that you have a negative number, if x is negative, you will take the logarithm of the function nonetheless, but we have to use the absolute value of the function. What does the absolute value say? The absolute value says that if this is a negative value, it is going to become positive. So if this answer was ln of -3, the mere fact that you have ln of -3 becomes ln of +3. And then that's what you can evaluate, because you can only take it of the positive number. So that's what I'm saying to you. In this question, you may ask, why then, sir, you had the x minus x plus 1 in parentheses, when it is that, you could have just leave it as ln x plus 1 in brackets. If you had left it in brackets, I would mark it wrong. But what I'm saying to you is, in this particular case, because it's an indefinite integral, you don't know what the value of x is. You have no clue. What if the value of x were -2? It would be -2 plus 1 should be -1, and you can't take the logarithm of that negative number. So that's why to be on the safe side, I just put it as the absolute value of x plus 1. Should in case x is negative and it's -2, -2 plus 1 is -1, but the absolute value of -1 is +1. All right, so when you're finding the absolute value, you just drop the negative sign. That's what it is technically. And then you can evaluate the question. All right, so that's what that one said. This one is very similar. Oh Lord. No, that's not what I meant to do. Okay, let me go back here and paste that right here. And then go here and then do this. Oh, come in, guys. This thing is sticking. And then put this in parentheses. And then put a negative 1. I don't know why math is so challenging for some students, when it is that you have set rules to follow. All right, look at what is happening here. They asked me to do this stuff, integrate this stuff. This 3 up here is a constant. I'm taking it out right here. Remember, when I'm integrating my functions with the constants, take them out. Take them out, right? Because this is now that I take it out, I can now see that this is 1 over x. Sir, 1 over x, I say 3x plus 1, yeah. I'm using 3x plus 1 to represent x. So it's 1 over function. See here? 1 over function. See here? 1 over function, right? So once you have 1 alone in the numerator, not 3 and 2 and 5 and 6, you must just have 1 alone in the function up top. In the rational function, in the numerator, you must have 1 alone. And then in the denominator, you can have anything. Anything at all you can have in the denominator. Anything. 2x squared minus 5x plus 6. La-di-da, la-di-da, la-di-di. Anything at all in the denominators. Once you have a 1 in the numerator, that's when you recognize it's going to be an ln function.
Hold on, sir. Hold on. With the question here, you take out those 3. You just multiply, like you move the which rule is again? You move the 3.
And the 3x plus 1 and the square to the numerator to get the negative 1. So all I'm doing is taking this 3 out. Then I'm going to be left with 1 over 3x plus 1. And this 1 over 3x plus 1 is the same thing as 3x plus 1 to the minus 1. When I see this, I recognize this to be the ln function.
Oh, and then the multiplication sign come back down because
hold on. This piece I'm going to explain now. This piece I'm going to explain. This 3 is this 3. When I integrate 3x plus 1 to the negative 1, I'm going to get ln 3x plus 1 plus c. The same explanation I gave for this one, why I have the absolute value, because it's an indefinite integral and I do not know the value of x. I'm going to put my answer in absolute value form. So there's going to be ln, the absolute value of 3x plus 1 plus c, which is this. All right? Where does this 1/3 come from, sir? This 1/3 comes from me differentiating on the inside of the function and reciprocating it. That's the only new thing that you have to learn. All right, so all right, so what this is, and I want you to just pay attention to this, quite not hard, What this is saying is, and let us go through this again, because I'm not giving you more than 3 questions on it. I'm not spending a whole lot of time on this area. Really and truly, I'm not spending a whole lot of time. So I'm going to give just one more question and then we'll move on to something else. Let us look at this here. So we have the integral of 3 over x over 3x plus 1. 3 over 3x plus 1. What it is saying is that because the 3 is here, I am trying to find it. I'm trying to see if I can write it in the form 1 over the function, because I know 1 over the function is the same form as 1 over x. 1 over x is just really a general form of the integration, a general form of the integration. So because we know that whenever we get a question on integration, we're going to be factorizing our constant. Now the 3 is my constant, so I'm taking out the 3. I can do that. I've shown you that we can do that. So we take out the 3. I'm left with 1 over 3x plus 1. I'm left with 1 over 3x plus 1. Now that I have the 1 over 3x plus 1, I'm going to rewrite it in the form 3x plus 1 raised to the negative a half. When me see that me write it like that, me know me have the ln function to deal with. So this is this line, 3 x plus 1 to the negative a half. My 3 is still on the outside. So this question is the same thing as this, is the same thing as that. I'm only rearranging and simplifying. But watch me now. This 3 is this 3. When I'm integrating here, I'm just going to put ln and write back everything here, so plus c, because it's an indefinite integral. So I'm going to write ln 3x plus 1 plus c. But sir, you have it as an absolute value. Yeah, man. Because remember, it's an indefinite integral. I don't know what the value of x is, and we can't take the logarithm of a negative number. So to be on the safe side, I just put it as the absolute value of x. To be on the safe side, I just put it as the absolute value of x. But sir, where the 1/3 come from? Remember that you have to differentiate the function itself. And when I differentiate 3x plus 1, I'm going to get 3 because the differential of 1 is a constant and it's equal to 0. And when I do that, when I get my answer, then I'm going to reciprocate it, meaning that I put 1 over it. So this dot is the differential of that. And then when you multiply 3 by 1/3, you can get 1, which is outside here, so, and I don't have to write it, as Kimani asked earlier, or did in one of the other questions. If you write 1 over here, so I will mark it wrong, Kimani, same difference. And I'm just going to have the ln, the absolute value of 3x plus 1 plus c, and that's my final answer. And
sir, you melt my brain a while ago, sir. You melt my brain a while ago.
So you can do it again.
I'll cross multiply, yes, sir, and get rid of that 3 there, come cross, yes, sir. Right here, so we just have 3x over 3 times 1 over 3. Cross across,
yeah, I just multiply 3 times 1/3.
Yeah.
You only cross multiply when you have an equal sign. So
equal
that's
sign,
not, right. So I just multiply. All right.
Sir, you need to go back over that again, sir. I mean, like, all right. Let me explain what we get, this, sir, right? The first part, I understand you rearrange it because you say it's the same thing, but you rearrange it so it's easier, right? The third line, this would be the second line of working, where you equate it back to 1x raised to the power of 1. Cool. So you know that is ln, right? That is ln, and you write back the function as you say, because it's a what you call something that
absolute value.
No, is a absolute, right, cool. And then you put back the dx at the end. Fine, but get that part there. Now, where you get the 1 over 3 now is where you say you're inside of the bracket here. So you say 3x plus 1. What you do in here, sir? Forget that back. Forget the 3 by itself for the 1. And why we couldn't do it in a linear fashion? Or rearrange it, sir. I could have put the 1 over 3 at the end plus c.
Yeah.
Could I do that? Oh. So I wonder why it looked like it worked back way. So you differentiate the inside of it, inside of the absolute, in order to get the outside, the bracket. So you put back the 1 to get the ln. Oh, okay, sir. I get you. In order to get the ln, you eliminate the negative raised to the power of 1 first. You put that, and then you differentiate inside of the brackets, which give you the 3, which you have to put back over 1. Why do I have to put 1 over it again, sir? Why will put the 1 over it again?
You have to reciprocate it. That's just a rule. You have to reciprocate it.
All right, put it back over 1. Okay. So when we have ln absolute 3x plus 1 over 1 over 3 plus c, that me have. So maybe you want to know why it come at the front, tester, sir. Why you have it at the front? That wrong?
Same difference.
Same thing. Okay. All right. Cool. All right. Shani, so explain it to me later, sir, if anything.
that's at the beginning of the class, the beginning of the class.
All right, so let's go. All right, let's go again. So what I'm saying to you is, so this is my question. I'm factoring out the 3 because it's a constant. Then I am left with this. I'm converting this as 3x plus 1 to the negative 1. I recognize this. A lot of these, press pause. And I want to hear this story. I went to a math conference some time ago in Philly. But the year when I went to the math conference, they had an outbreak of mad cow disease. And there was talk, couldn't prove it, but there was talk of North America using horse meat as beef. And that was the genesis of me stop eating beef with the whole mad cow disease business. Eh? So the truth of the matter is, when I went to the supermarket in Philly, because I decided that, you know, when you eat out, you spend more money. Maybe I buy my food and buy 2 pieces of something and cook it. I had an Airbnb. I'm gonna cook it. That can last me breakfast and it can last me dinner when I come back home. And every time you buy a food at $20, and by the time you look, I want $20 for breakfast, I want $20 for lunch, and you want something to snap on a $60 that, and I can use $5 and buy a tray of meat and just put on little salt and pepper on it and I meat that. So I save one for money. I went into the supermarket and I looked at the meats and I couldn't tell you whether or not it was cow or horse. And you know what I did? I left it alone. Now there are other people who may look at it and say, no, this is not cow meat, this is horse meat, right? But I was able to look at chicken and tell you that it's not frog, but it's chicken. All right? So just as how you can go into the supermarket and differentiate your types of meat. When you go and see salt fish, you know that it is salted fish. When you see salted mackerel, you know that it is salted mackerel. And you can differentiate salted mackerel from fresh mackerel too, because the salted mackerel, you should see the salt crystals on top of the mackerel. All right? What's the point I'm making? The point I'm making is even when you freeze your meats and you look at the frozen meat, you can say, no, this is a mutton, this is the steak, this is a chicken. This is how I want you to look at the mathematics and say, no, I have to use this rule to work it. Because remember, no, you are going to get the doctor of the class. In your own rights, outside of the business calculus students, in your own rights, you guys are doctors of computers. I take my computer to you and I give it to you. You can look at the computer. You can say, okay, sir, what happened when you turn it on? What happened when you turn it off? All right, maybe the hard drive is going bad. Do me a favor, sir. First thing I want you to do is to back up your stuff. So you start giving me solutions to the stuff. So in case you go in there, something goes awry and you lose the information, at least you have it. And even if I don't back it up, you can put it into the cloud, or you can do something to just, recover the information on the hard drive, right? But you in your own rights are doctors of the stuff. So you're going to look at the stuff and you're going to say, okay, this is one of the first things I'm going to be doing. Don't be like one of my friends, lives in Canada and works in the United States. So she drives across the border every day. And she says to me, Redrick, if I have a bottle of Pepsi, a hot bottle of Pepsi in my car, and by the time I drive from Canada through the border to go over to the United States, it is very cold Pepsi, and I don't have the air conditioner on in the car, I have the heater on. She said if she leaves the Pepsi in the car, when she comes home, it's frozen. So she says to me that because it is so cold, it is bursting pipes. She said that what they have to do sometimes is to leave the refrigerator open, because if they leave the refrigerator closed, it is going to form ice on the back of the thing and burst the stuff and radiate it. So they just leave the refrigerator open. So at least it regulates the pressure. She said one day she went home and the fridge not working. And she's like, Lord of mercy, what is happening? And she called the person to come and repair the refrigerator for her. And the guy says to her that, there's nothing wrong with the refrigerator, it's just that it was unplugged. But because I had to drive from one we call it now, province to the next, I have to charge you for my transportation. I won't charge you for labor, I have to charge you for transportation. No, she spent about $100 and something just for somebody to come and plug in our refrigerator. What's the point I'm making? There are some diagnostic stuff that you must do before you can say, this is beyond my scope. And this is where you students come in. The business calculus students come in with them administrative skills. Did this happen? Did that happen? Did that happen? And if all of those things happen, then they escalate it to the other level. This is what you're doing with mathematics. So you see the question, watch me. You see the question. 3 over x over 3x plus 1. What you're going to say to yourself is that, okay, I can factor out the 3. You're following the rules. So you factor out the 3. Then you look at it and you say, but hold on there. This is 1 over a function. Sir say anytime I have 1 over a function, I will call it 1 over x. But it's just that x in this case is all of 3x plus 1. Then we're going to have the ln function. So all I have to do is put 3, then I put the ln, and then I put the 3x plus 1 to the ln 3x plus 1. And sir said because it's an indefinite integral, I don't know the value of x, it just put the absolute value. And then sir says, all you have to do is to differentiate the function and then reciprocate it. Let me read what I have. Remember that you now have to differentiate the function and then to reciprocate it. That is, and this is now me giving you the explanation. That is, differentiating what is inside the bracket, theta, 3, and I'm calling it y to be equal to 3x plus 1, right? And then when I differentiate it, therefore, I'm going to get dy by dx to be equal to 3. So that's differential. And then we're going to reciprocate the result to give me 1 over 3. And that 1 over 3 is this 1 over 3 here. So you have to differentiate what is inside. If you don't differentiate what is inside the brackets, you are going to be wrong. Now, Everton's contention is that it can differentiate it because we have been differentiating it and putting it outside here. It's neither here nor there. It's a multiplication. And multiplication means that you can do anything, anywhere, at any time, and still get the same answer. So what I'm going to have is 1/3 times 3. So we can have the 1/3 out here, say no. We can have the 1/3 out here, so. But if we still multiply the 1/3 that is outside here, so by this 3, 1/3 times 3 is still going to give me 1. So I'm still going to be left with ln, the absolute value of that. It doesn't matter. Do me a favor. Oopsie daisy. Do me a favor. I'm reducing this. I'm leaving that open. Do me a favor. Let me reduce it by 1 more shot. Do me a favor. Try this do now for me, please. Quickly, and then I'm moving on.
And then 3x plus 3 plus 3.
Somebody was giving me the answer just now. Who was that?
With me.
All right.
So you leave us number 3 to do, right?
Yeah, man.
I just take it away.
So ln 4x plus 3 plus c. 4x plus 3 in differential bracket. In wait in the bracket. In
Absolute value.
Absolute values, yeah.
Yeah, very good, Emilio.
So as usual, I mean, I don't know how I'm working out, you know, but just guess based on the answer where you have up this.
And that's fine, but it's just that you need to now learn the steps in between. All right, I'm giving you guys 2 more minutes and then I'm moving from here. I really want to maximize today. It's now almost 11 o'clock. So technically we have just 1 hour left and I really want to maximize by getting some more of these things done up. All right, 2 more minutes, soon come.
Anybody finish it?
Yep.
All right, make it 4 ln absolute 4x plus 3 a quarter plus c.
Where's that?
Times a quarter plus c, but finish it now for me, please. You're correct. Finish it for me now.
Oh, okay. You think you must say that answer.
Sir, so we're just gonna multiply the 4 times a quarter, which I gonna give you 1.
Oh, you know, so you may have one. Very good, Everton. That's the point I was making. So whether or not you have it at the front or the back, same difference. So you will multiply the 4 by the quarter, you get 1. So all you're going to be left with, as Emilio says,
ln
the
is
absolute
the
value
ln
of
absolute value of 4x plus 3 plus c.
Very good.
Okay.
Sir, I did mine. I got that too.
You got that for the answer? Very good. Now,
Sir, ln 4x plus 3 plus c.
very good. Now, is it because me now go right out to something, so we're just going to write that as an answer there because you are following the steps up here. Excellent. Very good, guys. Very, 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 very good. All right. Now I have one here for you.
Sir, the same indefinite integral.
This is the same indefinite integral, right? So I'm happy that you touch base with the indefinite integral trainings because we want to spend the other hour with you, and this will also benefit the business capital students. It will benefit everybody here. I really want to move from my indefinite integrals now to my definite integrals. I want to move from my indefinite integrals to my definite integrals, right? So I'm happy that you made mention of this. Yeah, so this is still indefinite. This is still indefinite. This is the last indefinite that I give you to do for me in class. And then I'm going to be moving to the definite. All right. So I'm giving you one other question. This is icing on the cake. Please, all of you get it right for me. So don't shout to the answer. I want you to do it. And then I'm going to be, we're giving everybody enough time to get the answer done up. So I give you 3 minutes to do this for me. 3 minutes, and then we do this. And then I'm going to just use that over to go through the the definite integrals. But press pause. Let me just clear my thought here. The definite integral should not take me a lot of time. You know why? Because the same methodology that we use for the indefinite integral will be the same methodology that we use for the definite integral, except that we have an extra step to go because we're not going to have the plus c. We now need to evaluate what that plus c is going to be. And that's the only other step to do, right? So I want to spend some time on that, teach it, give you some questions. Once we get that all right, good to go. We can sail. All right, 3 minutes. Start.
Sir, the ln function, ln can be minus, right?
You can have a minus in front of the ln, it's just that the function in itself. Remember, the function is what comes after the ln. That can be minus, but you can have a minus in front of it. Yeah.
All right, cool.
Sir, that one here tricky too.
Sir, we can have a ln within a ln.
It's just, no, that wouldn't apply for this question. But it's not tricky, you know. This one is just using this question number 4 is like what we did for question number. All of these that we've been doing with the individual, not just 9. All of these is just that we have many terms, but one of the terms is just a ln, and you will get questions like those. So it's not anything, in a hard man. Just go through. 1 more minute.
So 1 ln 8x plus 5. Sorry, negative 1 ln 8x plus 5 plus c.
Careful, remember you have to integrate each term.
So it looks like you have to do that one. Oh.
All right. Watch it. I'm integrating each term, so this is going to be 8x to the second power over 2, see it here so, plus 5x, see it right here so, minus is this minus here, Everton, and then the x to the minus 1 is also going to be ln x plus c. 2 into 8 was 4 times, so we get 4x squared plus 5x minus ln x plus c, and it's done right, listen.
Something like that, just
Yes, sir.
put it over the 2.
You remember, you know, as I keep saying, you are integrating individual terms.
Sir,
yes, please.
Surprisingly, sir, we get that. I got it.
Very nice.
I got it.
You need to switch to weekend college.
Sir. Go back through it again. Let me see where I'm going wrong.
All right. You remember this, right, Everton?
Yeah.
I integrated this, then this, then this, then this, then this. And I got this line, and then I simplified this line to get this line. So most of the questions are written in 3 lines. Once it is that there's something to simplify. This one I never had anything to simplify, so it's 2 lines. This one I had something to simplify, so I have 3 lines. Let us jump to this one here now. I have 3 terms. It's similar to the ones that we did in question 1 to 9 that we did just now. However, this one now includes the ln function. And you will get questions in the exam to do mix up like this with the ln function there. All right. So I'm saying to you, when I'm integrating here, 8x, it becomes 8x squared over 2. See here, so because I still have to integrate. Remember, you know, it's not 1 over something, you know, or 4 over something, you know, where you can treat everything as a whole function.
That's how we have to, sir.
No, you can't treat this as 8x plus 5 minus 8. No, it's not 1 over that.
So you know, so one time I do it, and I say, what? I'm a fraction, so what me I do?
That's the point.
I'm a rub it out.
Very good, Peter Gay. It is not fraction. So once it's not fraction, don't think this. That's the point I was making. When you go supermarket and you say beef, you know a beef. When you say chicken, you know a chicken. When you see them mad, say you're supposed to know which is which. So that's why I'm trying to mix it up so it is that they can be able to identify. Watch me.
Catch me.
Never mind. It won't catch again. Let's go. So this one here now, I'm integrating individual terms. So 8x, when I integrate 8x, I'm going to get 8x over 2, 8x squared over 2. When I integrate 5, I'm going to get 5x. No, this minus sign, this is minus sign. So that's what Everton was asking. Sir, you can't have a negative upper sum. I said, no, this negative sign is in front of the logarithm, so it doesn't affect it. It only affects it after it comes in front of the ln. So what happens now is, this is x to the minus 1, but you know that this is just x to the minus 1 and not 3x plus 1 to the minus 1 or 4x plus 3 to the minus 1. It's just
so that falls back to a ln.
It falls back to a ln x, yeah. Because really and truly, you know, what you're not seeing here, we're actually differentiating 1. Rubbish. We're differentiating x to get 1, and then we're reciprocating it. But 1 over 1 is the same thing as 1. So we don't have to show all of that. We just write by the ln. So that is going to be our final answer. One last one. I don't like the mood. There you go. 3 minutes. Who got that as an answer?
Me, sir.
Yes, sir.
Never get the minus 3x back.
All right.
Sir, the only, sir,
Mm-hmm.
my only difference is I put 7x ln instead of 7 ln x.
Okay, yeah, the ln has to come before.
Okay.
That's what I did. That's what I did.
Right. So just remember the ln has to come up. And guess what? It's work in progress. Thank you. Thank you for I mean, to the class for being very diligent with this. I have 45 minutes with you. And hear me out. I want these 45 minutes to be very, very purposeful. Some of you ask them to just relax on yourself and let us go with what is about to face you now. And you see it here, it says definite integrals. It says definite integrals. Now, here goes a question. Here goes a question. It says for me to find a definite integral x cubed plus 3x plus 2 dx. And before I go to the definite integrals, let me just give you a little story behind this. Now, Dawson, Candice, she's an only child, and her father left her a nice piece of land. Really and truly, she go to school.
Sir, you know that.
A real talk?
Yes, sir.
Same thing, you know. And I really hope that everything else that I am saying will be true, because it's all good things I'm going to be saying. So her father left her a nice plot of land, but Candice will go to school and Candice she not have the money to go deal with it yet. But she have a nice plot of land, I mean, good view and the whole works. But there's one problem with the plot of land. When the surveyors look at the plot of land, they recognize that it is not yet fully prepared for construction because it is a bit rocky. So she has to now go and prepare the plot of land for construction. Now the surveyors will say to her, say, no, miss, we can, is solid, is bedrock down there, say no, is not no little shale where if earthquake come it will crumble. A solid bedrock down there, you know. So, you know, if we drill through, we can build a house, you know, but based on what will happen, we can't build a 2-story because it means, based on where the plot of land is, it will compromise the stuff. So I would recommend as an engineer to dig down, to blast some of that bedrock so it is that you can get a 2-story out of it. And Candice said, oh, you know, so many have that in mind. How much you do it? And say, well, you know, kind of expensive, you know, because to go rent the backhoe and rent this and do that, it's about 500,000, you know, to say, you know what? Let me do it. I'm going to build one level first, and when things, all right, let me just put another level up on top. She say, no, him say, you know what, that can't work, you know. So Candice blast the place. Now, how does that relate to this? Candice will have an upper limit and a lower limit. So Candice now have 2 lots in one because it number from 1 to 3. So she have lot 1 to 3. So she have one big lot. Her father left here, you know, big lot. So what Candice need to do now is to calculate the area of this plot of land. So that Candice can say, here the plan, you know, say, me alone can't live on a plot of land, you know, so we can sublet it and we can make a money off it, you know. We can divide up the land and make a money, and the money we make off of the land and it will build the house. Right? Or what Candice can say, you know what? We just have finished off my bachelor's at Exeter, you know, I have no money for do nothing, but my old man left piece of land. And then Everton, the developer come and say, oh, who own the land here? Oh, nice, Mr. Line, I can get a couple of apartments out right now. Everton go land agents and them say, Candice Dawson. Her number is 119. Everton, the developer called and said, hey, my name is Everton Kelly. I'm a developer and you have a nice plot of land. Do you have any plans for it? Yeah, just finish school. Can't do anything just now. And the developer says, I can purchase it from you. I'm saying, how much? It's a nice plot of land. So the developer can say, I can give you 50 million for it. And Candice say, what? 50 million? She said, all right, talk to me. And then Candice come to Mr. Shand and say, Mr. Shand, you know, so I have a plot of land and the developer wants him for 50 million. I said, Candice, hear the plan. Tell the man, say, $50 million can't buy one apartment in a Kingston, because the apartment in a Kingston is $25 million. So do me a favor. Tell the man, say, if you give the $50 million, you sign over the plot of land to him. And when him done develop the place, him give you one of the units then. And Tim say want a 2-bedroom unit. And Candice go back to Everton and say, all right, Everton, guess what? Mr. Kelly, sir. Yes, we can agree for the $50 million for the plot of land. But I am going to request a middle floor unit, a 2-bedroom middle floor unit. The developer will, I will tell you the developer is going to say yes, because the developer can get all 8 to 10 units out of that plot of land, right? And then giving Candice one of the units is neither here nor there. Him not lose. Him not lose. So Candice win-win, you know. She never have no money to build a house. Somebody build a house for her. But plus, she have a $50 million put on. And this is what is happening in Jamaica as it is just now. I don't know if any of you live in areas where you see people post up something on light post. We buy houses cash. You understand? That the man them have to write about now because they don't have the land. So they will, and guess what? They now go through no bank to go get no loan. They're giving you the $50 million cash. So Candice can say, yes, I agree to that. And by tomorrow, she gets her $50 million right there and then. All right? What's the point I'm making? The point is these developers now will say, if me, I forgot to give Candice one of the units, me can't build a 2-story building again. I forgot to build a 3-story building so that we can make back some more money out of it. So the developer decide to calculate the area under the place. So the man can say, here the plan, we're going to develop and put the basement as the car park, because the plot of land is not big enough to hold 10 units times 2 husband and wife car, so it can't hold 20 cars. But what can happen is that it can do a basement level where 10 cars can hold under the basement and 10 more cars hold in under something, or 20 cars hold under the basement, and then you have the other, the yard space for visitors parking. And I'm saying this to you students, trust me, this is what the developers are doing, not only in Kingston and St. Andrew, but doing right across Jamaica right about now, right? Integration is what it is. Watch me. The integration is similar, is exactly what it is that we did for the definite integrals, except now that we are going to be doing a little bit more to calculate the area. Because once you're integrating a definite integral, you're calculating the area. There is no more constant of integration because you're getting a definitive answer. Watch me. And work through this with me, please. Come, unmute and work through this with me. Let us integrate this together. When I integrate x squared, what do I get?
X to the cube over 3.
Over 3.
Very good. Excellent. When I integrate 3x, what do I get?
3x squared over 2.
3x squared over 2. Very good. When I integrate,
over 2, yeah.
Very good. When I integrate 2, what do I get?
2x.
2x. Very good. So that's exactly what it is that we're doing. Look, sit here, x cubed over 3 plus 3x squared over 2 plus 2x. The integration done right here, say no. Press pause. Do you now understand why Sir says we're now going to do no integration with them 1, 2, 3, 4, 5, 6, 100 lines here? So we're going to do the integration in 2 lines and at most 3 lines? Yes, because when we get the definite integral, we don't have them long something if we go work out. The definite integral, the integration done in a one shot. Bam, x cubed over 3. See it so? Bam, 3x squared over 2. See it right here so? Bam, 2x done. But because my up here represents my upper limit, down here represents my lower limit. And it is always going to be the upper limit minus the lower limit. It's always going to be the upper limit minus the lower limit. Always going to be the upper limit minus the lower limit. Always going to be the upper limit minus the lower limit. Every single time. It's always in front of that. Huh?
The always in front of that.
I don't hear that. Always. Oh, yeah. Always. 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 Upper limit minus the lower limit. Every single time. You won't have anything else to do but that. Always the upper minus the lower. Every single time. Watch me now. This is my integrated stuff. You notice I don't have my elongated S again because I would have already integrated. When I get rid of that, when I do my integration, I am getting rid of that sort of that sign. Watch me and pay special attention because this is not difficult. You see, anywhere in the integrated stuff, I see X, I'm going to put in 3, and then when I put in 3 in all of them, I'm going to subtract it. Hold on there. Let me just do something here, guys. That is blue, and this is and that one is pink. All right, I just color coded my limits. So anywhere in the integrated stuff, I see X, I'm going to put in the upper limit. And when I don't do that, I'm going to minus. And anywhere in the same function, I see X, I'm going to put the lower limit. And then work it out until I get my final answer. Watch me. This is x cubed over 3. It now becomes 3x cubed over 3. See here? 3x cubed over 3. I don't finish it because I have more to put in with the 3. 3 times 3 squares over 2. See here? 3 times 3 squares over 2. And I have one more forgot. Plus 2 times 3. Now that I've finished putting all of the x's, all of the 3's into the function up top, I'm going to say minus. It is always a minus sign. Minus. And then I'm going to put the lower limit now. Same function. Please, in Jesus' name, this is not the function we're using. That's not the function we're using. It's an integrated function we're using. So it's going to be 1 cubed over 3, see here, 1 cubed over 3, plus 3 times 1 squared over 2, see it right here, so plus 2 times 1. Now, when I do that, I am actually not supposed to have that there. I don't know why I have that there. So I'm not going to have anything here because right here says where I have the 3, 1. I would have substituted my 3, 1 here. So I am reducing my question. No, is where integration done right here. Please say no. Integration finished right here. So algebra we do right here. So no. 3 cubes is 27. 3 times 3 is 9 times 3 is 27. So we're going to have 27 over 3. Watch this. 3 squares is 9. And 9 times 3 is 27 again. So we're going to put 27 over 2. And 3 times 2 is 6. So we're going to have 6 right there. Hold on a minute, please. All right. Sorry about that. All right. And then no, 1 cube is going to be 1/3. 1 squares is 1. 3 over 2 plus 2. And then we'll just work out yourself. Please do not ask me, sir, how did I get the 57 over 2? All of this here works out to be 57 over 2. All of this here works out to be 23 over 6. And when you work out all of this, you can get 73 over 4. Ask me your questions now. This is little school maths, and I'm not here to teach you little school maths. So ask me your questions now. based on this because I have work for you.
Teach
And
me the
this is what
liquor
we'll
school
do.
maths.
No, sir. Do me a favor. Just get your calculators for me and put, you're going to open, matter of fact, get your calculators, all of you. Get your calculators, all of you.
27 plus 27 plus 6.
No. Yeah, you can do that. But what you can do for me is open your parentheses. Just as I have it typed, this is what you're going to do. Open your parentheses. Then you can press 27, ABC 3. Hold on. Hey, you know, so me a spoil on you, you know. But really a spoil on you, you know.
So you want to get AC, you have to spoil.
True that still. All right. Let me give you the algorithm.
Sir, I like my calculator.
Nice.
I like it a lot.
Man, don't it work it and give it to you, right?
Sir,
trust me.
My calculator, I did the same thing on the screen with my calculator.
Excellent. And that's exactly the point. So let me just show you. So you're gonna press 27, then you put the A, B, C. 3 plus 27 A, B, C 2 plus 6 equal. Don't do this to me now.
Sir, I'm gonna put it out exactly where it's there and it give me a error.
No,
but for my calculator, I have a little
division button.
Oh no, not a division button. It's a thing will show you like you have a faded out
natural
box at
display.
the top.
It's a natural display. Good. So the natural display calculator, what Everton is saying, the natural display calculator, when you press the ABC, you get a numerator and a denominator comes up immediately.
And an ABC it markers though, but yeah.
No, yeah, it is marked as a numerator and denominator on the calculator.
Yeah.
Like a little square box divided by another square box, right?
Yeah.
So if you have a natural display calculator, just press, where's my calculator? Let me tell you exactly what it is. My calculator has, my calculator has the same ABC, capital A, B, and C. Let me just put it how you see it on the calculator. My calculator
capital A and then the B above the C.
Right. The B slash C.
When I see that on my own.
A,
I just see the natural button.
Yeah, how to have it? Yeah, B, C. Come on.
Come on. Do it.
Sure.
Just do it.
All right. So on the calculator, you see it like that. 27, you're going to look for the ABC button and you press 3. Then you press plus. 27, ABC 2. Then you press plus. Then you press 6. And you should get 57 over 2. Try that for me, all of you.
Okay.
Mine said 28 and a half.
Same difference.
Same
difference. Same difference.
Yes, sir.
Excellent. Same difference. Excellent. Wow. Is so much easy? 28 and a half.
Sir, I'm on a downward spiral, I know, sir.
No, it's the same thing. Same thing. Peter Gay said, wait until 11 o'clock.
11:30 now. She miss it. 11:30 now.
So it's a pattern. So it's a pattern with Everton. As you reach 11 o'clock, same brain starts shut down.
All right, then come. Look. So very good. So you know how to use a calculator. So hey, when I go to school, teacher, tell me them something here, you know.
Sir, that are working at the Stone Ages, sir. Stop talking about them something.
Did he just say that a while ago? I forgive him, Lord. All right, let's go. And you do the same thing for the other stuff. For the 1/3 plus 3/2 plus 2. All right? And you will end up eating this stuff. No, hold on. Sorry. Now, so that's exactly what it is that we do, and we end up getting our 74 1/3 for the answer. Don't worry about it. It is not difficult. It is what it is. It is what it is. I'm reducing this because there goes your question for the class. No, I'm giving you 5 minutes for that. Soon come 5 minutes. I'm muting 5
But I give
minutes.
you 5 minutes. Good, well, come myself. I gotta write down the exam plan, sir.
Sure. All right, then give you 10 minutes then.
All right.
All right, cool.
Sir, you there? Sir? Yo, what wanna get for the answer? For number 2. For the one. I get 8 over 11 and 3 over 3, which is equal -3. So 3 over 3 at 3.
You want to know much forget for my answer, man? I left that right. Hey.
All right, look on the trick question or me think or me get catch this up. Remember say all it bracket, you know. So when it bracket this, so it gonna say everything that's raised to the power of 3 already, right?
3 and
Yeah.
-8.
So then say you
That
end up
right.
with 4. Everything I raised to the power of 4. The first one I raised to the power of 4. The second one I gonna see a 3. Hold on.
Where that one? Anyways, we're going to circle.
All right. So when I integrate the 3, right? The constant, the -3. Cool. Wanna get 3 raised to the power of 4 over 4. No, a 3x I get. Three x. See if I do not mad if I'm madness, but yeah. 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 I get 3x. This a 4. Raised to the power of 4. Yeah. How did I do? What am I do this so? You know, I'm not trouble it. That's what sir say. And then I can retrack.
Finish? I guess not. Wanna finish? Talk to me now. Are you guys hearing me?
Are you for talk to me?
No, but
Yes, we are here. You let we know.
But look how number come back and ask if you not finish and nobody not answer me. All right, so let us go because I want to sneak in another question in between. So let us go. So anybody got -10?
So I'm gonna get -8. At 8 I get.
All right.
No, I'm gonna get the 8, but
I love your
Sir,
honesty.
I do something wrong. I can't.
All right, no problem. Let's go. So we get the function. We're integrating 2x. We can get 2x squared over 2. Okay, sorry. All right, guess what? Oh Lord Jesus, come down to all of we. I really shouldn't have given you this question just yet. No, I apologize. I didn't recognize what it was. Oh Lord, I didn't recognize what this was, guys. This question here has a different. Forgive me. I really ask for forgiveness. This question is a different application. I don't know why I put it right here. Forgive me. It's when I start, I recognize that it has a power to the third. So we just wasted about 10 minutes right here. I soon come. Don't erase what it is that you have. I'm going to come back to it. Forgive me, please. This is a different application, but it's an application that we need to know. So what I'm going to do.
I'm stressed out, right?
No, don't be stressed out. Don't be stressed out. I just made a blunder. When I looked at the question, I did not see that it was raised to a power, or else I would not have asked you to do it. I have the answer here. I will work it out with you. But in the meantime, I apologize. In the meantime, I want you to try this one for me. This one should be fine. I want you to try that one for me. I give you 3 minutes for this one. Just try that one for me. The other one can be solved, but it's a different thing, and I have not shown you that one just yet. And I never realized. Osh, that's why I'm not talking to come back. All right, go on with it. I'm right here listening on. Quickly. All right, come guys, let me just work through this one quickly for you. All right, so this one says um, 4x cubed minus 5x squared plus 2x minus 1. You're integrating individual terms. You're integrating individual terms. So this now becomes 4x to the 4th over 4 minus 5x cubed over 3 plus 2x to the 2nd over 2 minus x. And you're using your limits to be 3 and 2. As I explained to you, all of this, I'm going to substitute my 3, and I'm going to subtract it from, when I substitute the 2 in all of that. So anywhere in this integrated stuff, I see x, I'm putting 3. So that's why I get all of this here. I'm doing the same thing here, but I'm substituting 2. So let's go. 3 to the 4th is 8 to 1. It says 4 times 8 to 1 over 4. You notice I have not even cancelled out anything here. I don't have to. I can just do everything and the calculator work itself. 3 cubes is 27, so it's 27 times 5 over 3. 3 squares is 9, 9 times 2 over 2, and 1 times 3. 2 to the 4th is 16. 16 times 4 over 4. And this is going to be 2/3. 2 to the 3rd power is 8. 8 times 5 is 40. Well, let me not. And 2 2 is 4 times 2 over 2. And this is 1 times 2. Then when I cancel out these 2 4s now, when I cancel out these 2 4s, I'm left with 8 to 1. 3 into 27 goes 9 times, and 9 times 5 is 45. These 2 cancel out each other, so I'm left with 9. And negative 1 times 3 is 3. These 4 cancel out, I'm left with 16. 5 times 8 is 40 over 3. I can't cancel anything, so I write by the 40 over 3. These 2 cancel out, so I'm left with 4, and then I have the minus 2. And 8 to 1 minus 45 is going to be 34, 36. 36 plus 9 is going to be 45, and 45 minus 3 is going to be 42. And I won't try to do this right about now. I'm going to get 14 over 3. I'm going to do this. I'm going to get negative. I'm going to get 112 over 3, which works out to be 37 1/3 units squared. So you have to make sure that you have your unit squared right there as your final part of the answer. So that's what this one is. What I will do, calculus 2, is to send you this document now. Calculus 1, what I will do is to cut, this piece needs to go further down. I'm not ready for this piece yet. So let me cut that.
Sir, I have a request. The YouTube video link where you send, sir, you need to send the rest of them fast, sir.
I don't have any more to send.
Work like a sweet.
I don't have any more to send. Those are all the recordings that I sent.
So I don't have no more to send. You try to find them, sir.
No, I'm saying those are all the recordings that I have.
Listen, sir.
Right,
Attack Mr. Parchment, sir.
Here.
Leave a page, Mr. Parchment, sir.
Hello? You see the recent one? When you just click on one of the recent one, and it will show you all of the ones that sir recently upload.
No, I get what you say. I talk like for this one and the one from last week.
I said last week one already.
Him send it already?
Long time.
What? All right.
No, we're not getting about Monday.
My sincerest apologies, Mr. Shan.
Sure,
I hope you don't use your influence as a doctor to inject me with the COVID vaccine when I'm not ready.
Can we go? What we're going to do is as I said before, I'm going to send off this stuff here. I'm going to send it off. I'm going to trust that you guys go through the stuff. As soon as I get the recording for this one, I will send it off. And what I will do for the business calculus, students, what I'm going to do, I'm going to label this one as calculus 2/business calculus here. So business calculus students, you can pick up this one so you know that this one is the Saturday class that we have together. Fair enough?
Sir, which class are business calculus 2 and which one?
Okay, so you are business calculus, and the class that you joined today is calculus 2. But I want to label this class when I put it in the WhatsApp in the YouTube group channel as calculus 2/business calculus, so that the business character students can play back this recording to, get this understanding. Especially those who weren't here, we can invite them to do this one.
Sir.
Fair enough?
Sir.
Yes, please.
What me that say a while ago? Jesus.
So,
sir, may I have a all right, when you finish, when everybody finish, me tell you something. Just call upon me when you're ready to tell me after you finish explaining everything.
Yeah, man. Now, Philly, you were saying something?
So I was asking, when is the mid-semester?
Go on study and go on complete work online. The mid-semester, if you look on Educator's office, say that the mid-semester is there. Just go on do some stuff.
Okay, sir.
Last night, please, sir.
Okay, you want to open some for you?
Yes, sir.
Okay.
We, sir.
Yeah, for the business calculus. I mean, the mid-semesters are ready for all my courses. They're already on platform, but I mean, they're password protected. I don't release the password yet. All I want you to do is to complete and the assessments online and just get ready. If you don't do the assessments, there is no way you can complete the mid-semester and complete the mid-semester successfully. All right?
Okay.
That's all I'm saying. Anyhow, running later. Everton, you said something, Everton.
Oh, yes, I may have a discount on surveillance systems this month. If you want one, just pay me.
All right, then cool. All right.
Sir, remember to open the
I'm going to do it now. Yeah, man. All right. Take care, guys. Thanks for coming.
Okay, sir. Okay, sir.
Remember my own name to say.